Uh, 5, 5.5. Now it's the applications. As I said it before, so now let's take a look at the beginning of this. So the first thing is the compound interest, and I said the compound interest, we don't do this year. Hopefully that all of you have done this in grade 11. So this year we only do the growth and the decay. All right, the growth and decay. So here we have already gone through this in the previous chapters. There are two formulas. One is using log 10. The other one is using log E. I personally just wanted to focus on this one. Any of you interested in the log E, and you may want to do this by yourself. So now take a look at the example here. The example, you have a method 2 that uses the log E, but I only want to concentrate on this one. Okay, so this is a half-life. Basically, this is just a plugging the numbers in the formula, but you need to understand which number is for what. All right, so now take a look at this. This is 13 years. So this is the decay. This is the for one of the decay. For one of the decay means for the substance to go into half. It takes 13 years for the substance to go into half. So this is for the big T. Now find the time. That means you're finding the small t here. So the small t is you do not know. Now 80% of 5 grams. So what does that mean? Is that at the beginning, you have 5 grams. So this is your initial. This is your initial substance. And find the time for 80%. So now 80% of the sample to decay, that means that you only have 20% left. So then therefore, this one here is your final amount. You only have 20% left. So you consider the whole thing as 1. So then you put everything in the formula. And then from here to this step now is that you have to change it to a log form in order to solve the t, because as we said before, this is not the same base. So you can't really now change this one to this one, this side, and this side to the same base of exponential equation in order to solve for t. Therefore, you're going to change it to logarithmic equation. Now note, from here also, because we said in your calculator, you cannot calculate log base 1/2 of 0.2. So now there's another change that you changed it into a different base, which is base 10. So then up to here, then you just use the calculator and get the number, and here you go. So that is your final answer. Okay. Now I also personally find this question very interesting. That's why I wanted to talk about this. Now you take a look at these discrimination. It's not difficult. So at noon, which is 12 p.m., the temperature, the turkey temperature is this. Now after 2 hours, and the turkey temperature is that. So then how long would it take for the turkey temperature to become this one? And here I thought it's very easy for people to fall into a concept to think, oh, that's easy. This is very easy. You see this? From 75 now to 100, so the difference is 100 subtract 75, and then how long did it take the turkey temperature to change? Well, it took 2 hours. All right, so hey, well, isn't this just a rate? Isn't this just a rate? So then we got 25 divided by 2. Well, that is 12.5. That means this many Fahrenheit over an hour. Okay, well, if this is rate, then why don't I say from 175, from 100 to 175, then I will say this is 175, subtract 100. So you basically have to raise for 75 Fahrenheit. So in this case, oh well, I do use a bracket here. So in this case, well, I'm just going to have this one multiplied by the rate. So 75 multiplied by 12.5. Oh, by the way, it's a divide. Okay? Oh, sorry, divide here. And then I get my time. Note, because this kind of rate is linear, it's linear. However, it did not say this here, but if you needed to use logarithm or you used to use exponents to find the time, that means the rate is not linear. The rate is not linear. So then therefore, then what's happening here, then this means that you are from, your beginning is 75, and then your end is 100. And then it took 2 hours, right? It takes 2 hours. So now the rate you're calculating is here, you see, which is not this exponential growth for rate. So from here, you're going to calculate the x first, because from here is just divided by 1, right? The total time considered as 1 unit. And you got this one, and then you would have to calculate this one, t here now. And then from here, we're still going to change to log form. Now from log form, this base, now we're going to change to common base 10. And this is how you're calculating the total hours. All right, well then you have quite some questions to have fun with. And hopefully that you don't feel 5.5 is that difficult. If you do, please come over to ask questions.